Hello and welcome back. Today I want to make a 12 volts for in my lab, and yeah, why is that so difficult? Well, it's not at all. The only thing is you quickly have a lot of devices that need 12 volt, and really 12 volt, not 13.8 like normal. I have here this Monacore. It's 13.8 volts, and that is just too much because I really need 12. And it says here, for instance, this is my distribution amplifier for my lab reference, for my frequency standard, and it really needs between 11.7 and 12.9. So the best thing is to give it exactly 12, not 13.8. So that is not a problem because they provide an adapter like this. It's a switched power supply. Not everyone is really crazy about switched power supply, but they are very efficient. I don't know if this one creates distortion or not. Let's say it doesn't, then we still have well, not a problem, but we still have an issue because this one needs 12, this one needs 12, and I have another distribution amplifier coming that also needs 12, and maybe later I like to order from the same guy this BG7 TBL. I like maybe the frequency counter and the signal generator, because the Marconi's limit is to 1 gigahertz, and the signal generator I think can go up to 3 or more. So that would be interesting to also test the higher frequencies. But that means if I have all that, I already have 5 of these adapters. And yeah, you know, in every lab you always run out of these adapters on power plugs. So that's what I don't want. So I have here this big power supply. I'm gonna see if I can adjust it back to 12. And also I'm gonna put a little display for the 12 volts and how many amps it's using. And I think this is a perfect spot just to put here. I will cut the hole with my Dremel, and yeah, then I'm done with all these little things everywhere. Okay, it's open. We have 2 pots here in the back, there and there, and we can adjust that in the 2 holes here, and sorry, the holes here, and probably one is the current limit and the other one is the voltage. So I just hook up the voltage meter and we see. So let's do that. Let me put, these are nice. I bought this also on the Chinese website, and you can just connect any. Here I put a crocodile, and now I'm gonna take that out, and I'm gonna put a pin. So now I put a pin, and because I notice a lot of times you just want to earth that connection, and then I just put a crocodile, and with my pin I can measure, so it makes it very easy. But now I need 2 pins, so I'm just gonna put the 2 pins here. It says the 13.8153. So let's see if we can turn it. Okay, I found the correct trimmer, and it is the one in the back, and I can go here at 13.8, and I can go up to 14.1, but that's not what we want to go lower. So I turn it the other way, and then I end up with 12.5. Well, 12.5 could be good because we could go to 11, but I want 12. So we need to lose some more. So if I have 12.5, and how much are we putting on the bias of the drivers? Let's see. then we put here 13 volts, so that means we have a drop here. Oh, that's the transistor itself, so we are almost there. You know what I will try? I will just put a diode just between the bias and the bias of the driver and the control system, and then we should have 0.7 less, and then we should be fine. Okay, what I did now is just add an extra diode to the between the bias and the control circuit. As I did here, it looks ugly, I agree, but I just want to test how we are right now. So I hope, as it should be, that diode drops 0.7, and then we should be lower. And we don't. Okay, that was a stupid idea. I do have some voltage drops, but there is also a sense wire, so this regulated power supply is actually more advanced than I thought, because it just starts to feed more in. So in the end we end up with exactly the same. So that's not what I'm gonna do with. But I saw that in series of the pot that I'm adjusting, there is an extra resistor, so I'm just gonna put more there. So in series of the pot there was a resistor of 3.9k. So what I will do, because I want to be able to go both directions, I have here a little selection of pots, and also from China. It was not that expensive, and I'm just gonna put a 10k, because yeah, this one is almost halfway. So let me see if we can make it. Okay, this option is a lot better idea. We are here now at 11.3, and so this pot is already on maximum or on the lowest, and now here we can adjust some more, and now we are able to get exactly to 12. The only thing I like to test is what does it do in the load. So I'm gonna do a little load test, but nicely 12. Well, it's not nicely 12. What is this, Tony? Come on. This is 12. 1201. Okay, maybe on this one it's better to see for you guys. Okay, that's more like a fine tune. That's good. Then I'm gonna go a little bit up here, and then I'm gonna go with this one down. Okay. Well, that's 12 volts, I would say. What does he think? Yeah, that's 12.0067. That's 12 volt. So happy about that. I'm gonna do with, I will put some load to see what happens to the voltage. Okay, I have a little setup with 2 multimeters. It is still 12 volts, as you can see here. Here we're gonna measure the current. It's 1201, so I think it's still 12 volts. And if we do 1.16 amp, it still is 12.004, which is I think stable enough. Let's try if we can put 2 resistors, what the current will be then. Let me get 2 clips here. These clips are, the wires are not that thick, but it should be only like 1 amp, so that should be fine. Just make contact. And now we have 2.13 amp, and it's 11.995. So I think that is stable enough. We put now the amp and the voltage meter in the front. Well, just a quick test. I adjusted exactly on 12, but now I wonder if this one also thinks it's 12, because this one is going to be in the front, and I will just put the sense wire and the other wire together, because it is above 3 volts, so we don't need to do any complicated stuff. Put both of the leads in. Well, it's not that precise. It says 12.3, so I need to adjust that, and these can be adjusted in the back also, so let's do that first. This I really did not expect, because okay, it is not that precise, it's from China and whatever, it was cheap, but really here it says 12.01, which is 12, I would say. How many rounding you use? It is 12. Here it says 12.3, and that is 300 millivolts off. I think that's a lot. Well, maybe that's why it ended up on the cheap websites, but for me that is not even a bit off. Well, here it's in the back. It says, I will zoom in, wait. Here in the back it says I adjust, which I would think is the current, and UFV adjust, and that's the one I'm gonna turn, and you see it is very tiny, so we need to be careful, but I want it of course to display 12. So we're gonna carefully adjust. I hope this screwdriver is fine. Oh, wait. Something did happen, but it is super slow. Ah, here. Here you see? I hope you can read the display. Oh, yeah. I'm adjusting. Here it goes. Okay, that is 12. Now I wonder if I go up again. $12.2, 12.56. Okay, dat is goed. Oof, that is 12. And then this one also needs to display 12, so a little bit more. let's wait if we switch it on and off what it says then. Yes, now it says 12. Okay. Okay, we have that done. And I'm also worried about the current. That one we probably also need to adjust. But we see. First I will I will check that now. Okay, the amp meter needs to be on the negative side. So yeah, so you need to put it in the back of the circuit, and that has to do with the negative, with the earth connection. Now your minus, your 0. The 0 of the amp meter is connected to the 0 of the voltage meter. So you can see of the voltage meter I could just left the little cable off because it's exactly the same as the big black one. And don't forget to connect the big black one, otherwise all your current goes through this little one. But I will just tie them together and connect it there. So your terminal need to be on the red one, and then it goes back into the circuit through the black one. And the current meter is okay now, because it says now 12. Well, it's more or less 12. And then I put the power, and it says here 1.17, and here it's 1.61. So that is close enough. I can try to adjust a little bit, but my resistor is also getting very hot. And yeah, no, I want to do it. Okay, that is not good. How I can do this? Okay. The I adjust is this one. Okay. So now let's compare. 12 volts, 1 point. Yeah, that's 12. Yeah, this is not there. It is it has a kind of threshold, so it's very difficult to adjust. Yeah, now it says again 1.8. And now it says 1 point. Okay, well, I think this is close enough. It is not exact science with this meter, because you just put it on a setting, then you switch it on and off, and then it turns out to be a little bit different, but you more or less get an idea, and that is what I wanted now. And that's also to remind me that it is not 13.8 as it says in the front. It is really 12. And I just like to have a readout of the power I'm using. So that's it. I'm gonna build it in. Okay, making the hole with the Dremel seems to have worked. Here we have a huge hole. Hopefully it covers most of the damage I did. And yeah, let's try to fit it in. Okay, this is it. We finished the project. The meter I have built in, I connected the wires. I did make a little bit of damage, but I think it looked good anyway. If we switch it on, it says 12, and if we put the load, then 2.4 amps, and still 12 volts. So I think this is it. So if you're also thinking of throwing out all your little transformers or 12 volt and just use one big one, maybe this is an idea. and if not, at least it was a good idea for me. Thank you for watching, and I hope to see you next time.